Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. The algebra question on the 2016 higher level paper asked you to solve a modulus inequality. Find the range of values of x for which the modulus of x minus 4 is greater than or equal to 2, where x is an element of R, it's a real number. Okay, there's a couple of ways of solving this, and if it's okay, I'm going to do it a couple of ways. First method is to square both sides. Okay, why is this? Well, that modulus means that in usual cases, we just take the absolute value or the positive value. That is what the two lines down the side of it mean that's here. Okay, where would you have seen it? You would have seen it in coordinate geometry, where you looked at the length of a line formula. y2 minus y1 to be squared, okay? So if you think about distance we always just consider the positive value. So if I asked you the distance between Dublin and Belfast, for example, you might say something like 200 kilometres. If I asked you the distance between Belfast and Dublin, then technically speaking, that should be minus 200 kilometres because you're coming backwards. But we don't do that, we just go, 200, and we ignore direction. So in that particular case, the minus or the plus would signify direction. The other place that you would probably have seen it is in the area of a triangle. So again, in coordinate geometry, if you were considering the area of a triangle up here, you would get a positive area, and that's because the numbers here are all positive. Okay, if I happen to draw the same triangle, and you know I won't be able to draw the same triangle, but imagine that they're the same triangle here, and you just look at the numbers, can you see how you're going to get a minus area? Okay, but again, area is one of those things that we just take the positive value. Where it lies on a coordinate plane as such doesn't matter, the area is the area. So they're just two simple examples off your course where you consider just the positive and you do it without thinking. Okay, so what it means though is that in theory the number could be positive or negative. Okay, so what I'm doing is I'm squaring both sides to get rid of the ambiguity as to whether it's positive or negative, because when you square a number you always get a positive answer, and that's because minus by minus is also a plus. Okay, so once you square something, you are guaranteed it to be positive. So if I square both sides of this modulus inequality, I then know it's positive. Okay, so you get x minus 4 all to be squared being greater than or equal to 2 squared. Okay, if I square this, it's x minus 4 by x minus 4 being greater than or equal to 4. X squared minus 4x minus 4x plus 16 being greater than or equal to 4. Tidy it up. Bring the 4 over. X squared minus 8x plus 16 minus 4 is greater than or equal to 0. X squared minus 8x plus 12 is greater than or equal to 0. And again, you can use the minus b formula here to find the critical values, or you can use factorization where plus 12 is your guide number. 12 ones, of course I have the minus versions, minus by minus also gives me that plus up there, so any of the minus pairs works when it's a plus. I have plus 6 twos, I have minus 6 minus 2s, and of course I have 4 3s. Okay, so the question you're asking is which pair of factors gives me minus 8. Okay, so all of these factors here satisfy plus 12 here on the end, but only one line, one option will satisfy -8 in the middle. Okay, so -8 in the middle, so it must be -6 minus 2. Okay, so to finish off the factorization, split x squared into here and here. Then you have x by x. Split your plus 12 into the -6 and -2 that you identified here. And that's it done. Okay, so to find the critical values, I'm going to use the equals sign to solve for the critical values. X minus 6, so split the brackets, let each bracket equal to 0. Okay, so x is equal to 6, x is equal to 2 is the critical values. Okay. Okay. Is there another way I could have got to the critical values? And I haven't done yet. These are not my answers, but I'm going to park them there for a minute and show you the other way to get to the critical values. And then I'll finish off where we deal with the inequality sign here. We haven't dealt with that yet. Okay, or you know that could be plus or minus. So x minus 4 could be plus or minus. So in other words, x minus 4 could be equal to 2, or x minus 4 could be equal to -2. Okay, so bring him over and you get x equal to 2 plus 4, x is equal to 6. Bring him over and you get x is equal to -2 plus 4. Anything that comes over that equal to sign changes sign. X is equal to 2. Okay, so in this case, it was much quicker to get at it from your knowledge that a modulus or an absolute number could be plus or minus. Okay, so not finished, like I said. We have to figure out how to deal with that inequality sign. So I'm going to draw a rough graph. And in fact, it turns out that it can be easier to figure out your answer once you have the quadratic, because your critical values are 6 and 2. So they're over here on the positive side, okay? And I'll explain this now in a minute. So that's 2 and that's 6, okay? So when you solve a quadratic, you are always figuring out its roots or where it cuts the x-axis. So that's how I know it's over in this half of the graph. So 2 and 6. Why did I draw a smiley face? Well, I drew a smiley face because my quadratic over here was x squared minus 8x plus 12. The sign in front of x squared was positive. Okay, I'm now wondering, where is this graph greater than or equal to 2? Okay, so anywhere above here is greater than 0. Okay, how do I know that? Well, all my y values are positive here, or their numbers greater than 0. This is my 0 line. So anything above that 0 line is when we are greater than 0. In a similar way, anything below that line is when we are less than 0. Okay, so our question then is looking for when is the function greater than 0? Okay, well, I would argue that it's greater than 0 up here. This is our function, and that line goes on forever, and here. Okay, so how do we write that down? Well, to describe it, we say when x is less than or equal to 2, and how do I describe this side of it? Well, when x is greater than or equal to 6. And that is the solution to this question.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies. which uses cutting-edge techniques such as artificial intelligence, computer vision and virtual and augmented reality. You'll need a H5 in Maths to qualify. Check out the link below.